And now we move on to the last part of our discussion on motion along a straight line or kinematics. We have projectile motion. Projectile motion is what happens when an object is fired or thrown diagonally upward, horizontally or diagonally downward. Put in simple terms, projectile motion is free fall motion combined with uniform motion. Free fall motion on as the y component and uniform motion as the x component. If you are to divide the projectile motion of the object into its x and y component, the x component is characterized by uniform motion, whereas the y component is characterized by free fall motion. So the x component of the projectile motion, free fall motion, therefore the acceleration on the x component is 0. Free fall motion, the only source of acceleration is gravity. And acceleration due to gravity is vertical. It has no x component. Therefore, acceleration ax, x component of the acceleration, is equal to 0. So acceleration is 0. The velocity of the object is constant. So along the x-axis, the velocity Vx is constant. It is equal to delta x divided by delta t, or simply x over t. Whereas the y component, if you look at the y component of the projectile motion of the object, the y component is characterized by free fall motion. The acceleration source is gravity. Therefore, ay is just equal to acceleration due to gravity, and it is constant at this value, which means y component, free fall motion, y component is uniform acceleration, and you have 4 equations by which you may analyze the y component of the projectile motion. So you have 4 equations. Vy is equal to Vy initial plus gt. Y is equal to Vy initial t plus 1 half gt squared. Vy squared is equal to Vy initial squared plus 2gy, and Vy average is equal to Vy plus Vy initial divided by 2 plus delta y over delta t, or simply y over t. So you have the x component of the projectile motion and the y component of the projectile motion. Whenever you analyze the motion of an object undergoing projectile motion, divide the motion into its x and y component, and then analyze each component accordingly. So analyze x component separately from the y component, and then you can unite the two analyses using time t. Since there's really only one object that is moving, there's only one time of travel, which means the time of travel on the x component is the same as the time of travel on the y component. So again, when you analyze the motion of a projectile motion, of an object undergoing projectile motion rather, divide the motion of the projectile into its x and y components, and then analyze each component accordingly. You can unite the analysis of the two components using time t. So let's have a couple of examples. starting with sample problem number 1. From the roof of a building, a man throws an apple with a speed of 15 meters per second at an angle of 30 degrees above the horizontal. The apple lands on a balcony of a second building. If the balcony is 10 meters below the roof of the first building, how far apart are the two buildings? So you have building 1, building 2. From the roof of building 1, an apple is thrown with velocity v naught, angle 30 degrees above the horizontal. The apple undergoes projectile motion and lands in the balcony of the second building, of building number 2. The balcony is 10 meters below the roof of the first building. Determine the distance d between the two buildings. So first things first, divide the motion of the projectile into x and y components. In terms of our variables, divide the variables into x and y components. So for instance, acceleration A, divide the acceleration into ax and ay. Again, projectile motion, x component is uniform motion, therefore ax is equal to 0. Whereas y component, you have free fall motion on the y component, ay is equal to g, is equal to negative 9.8 meters per second squared. X is the distance, D rather, is the distance between the two buildings. The object will move from building 1 roof to the balcony. In terms of the X component, the displacement is simply X. Magnitude of X is the distance D, positive direction, therefore X is equal to positive D. On the other hand, in terms of the y component, in terms of vertical motion, initial position, final position. So initial position, final position. In terms of the y-axis, the displacement is y, vertically downwards, magnitude of 10 meters. Therefore, y is equal to negative 10 meters. We also divide the velocity into x and y component. Initial velocity, magnitude is 15 meters per second. Direction is 30 degrees above the horizontal. So divide that into x component, vx, and vy, y component. So vx is adjacent to the 30 degrees, so we use cosine 30. So we have Vx is equal to 15 cosine 30 meters per second. Vx is positive direction and uniform motion. Therefore, Vx is constant. On the other hand, y component, free fall motion. So, Vy initial velocity on the y component. Vy is opposite of the 30 degrees, so we use the sine function. So Vy initial is 15 sine of 30 meters per second. Vy is positive direction. So positive 15 sine 30 degrees meters per second. And we are looking for D, distance D. Now that we have divided the variables into their x and y components, analyze the x component separately from the y component. So starting with the x component, uniform motion again, you simply have Vx is equal to x over t. Isolate t, so you have t is equal to d over 15 cosine 30 degrees. Next, we analyze the y component. Free fall motion, that's basically uniform acceleration. You have 4 equations to choose from using y is equal to vyt plus 1 half gt squared. Note that we have an equation for t which we got from the y component. So using t is equal to d over 15 cosine 30. So replace t by that equation and plot in our values or equations for the other variables. We get the following equation. Simplifying, we have negative 10 is equal to 0.5773502,692D minus 0.02903703704D squared. You have transferring D to the other side, transferring rather this side of the equation to the other side, you have a quadratic equation. And again, quadratic equation, when you use quadratic formula, you get two answers. You have D1 and D2. D1 is equal to 30.9944927 meters. Whereas, if you calculate the other D2, that will give you a negative answer. And since we're talking about distance, distance cannot be negative, so we ignore D2, the negative answer. We'll just use the positive answer. We take D1 as the final answer. Therefore, the distance D between the two buildings is 30.994 meters. So again, just when analyzing projectile motion of an object, divide the motion into x and y component. So divide the variables into x and into y components. And then analyze the x component, uniform motion. Analyze the y component, free fall motion. And you can unite the two equations, the two analyses rather, using time t as we have done in this example. And now we have sample problem 2. You have a coin, slides off a horizontal tabletop at a speed of 5 meters per second and lands on a plate on the floor 2 meters from the foot of the table. What is the height of the table? So you have a table, horizontal tabletop. You have a coin, slides off the table, undergoes projectile motion, and lands on a plate that is on the floor 2 meters from the foot of the table. What is the height of the table? Let that be height h. Once again, we divide the variables into x and y component. Divide the motion of the projectile into x and y component. X component, uniform motion. Therefore, ax is equal to 0. Y component is free fall motion. Therefore, ay is equal to g is equal to negative 9.8 meters per second squared. In terms of the displacement, from initial position to final position, along the x-axis, the motion of the coin along the x-axis is from here to here. So this is displacement x, positive direction, magnitude is just equal to 2 meters. So x is equal to positive 2 meters. On the y-axis, from initial position to final position, the displacement y is vertically downward and magnitude is just equal to h. So y is equal to negative h. So we have acceleration, we have displacement. Let's now divide the velocity into x and y component. You have initial velocity. The coin slides off the table. The tabletop is horizontal. Therefore, initial velocity of the coin is horizontal. So V naught, magnitude 5 meters per second, positive x direction. All of it is in the x component. So Vx is equal to positive 5 meters per second. Since Ax is 0, uniform motion, Vx is constant. On the other hand, initial velocity on the y component, since all of Vy is in the x component, Vy initial is 0. And once again, we are being asked to determine the height h of the table. After dividing the variables into x and y component, we now analyze each component separately from each other. Starting with the x component, uniform motion, you have Vx is equal to x over t. If we isolate t is equal to x over Vx. We know x, we know Vx. So that's just 2 over 5. T is equal to 0.4 seconds. So the x component has given us the value for time of travel. Since there's only one object undergoing projectile motion, the time of travel on the x-axis is also the time of travel along the y-axis. So sa y component, this is also the time of travel, 0.4 seconds. Going now to the y component, you have free fall motion. You have 4 equations to choose from. One of those equations is y is equal to Vy initial t plus 1/2 gt squared. We know y. Going back to the previous slide. We know y. We know Vy initial and we know Ay. That's just equal to g, negative 9.8 meters per second squared. And since we have also calculated t, 0.4 seconds, we know Vy initial, we know t, we know g, we'll be able to calculate y. So plot in the values, we'll be able to calculate h to be 0.784 meters. And that's it for now. That's it for our discussion on projectile motion. And that's it for our discussion on motion along a straight line or kinematics. So thank you for watching.